Hello everybody and welcome to another geospatial webinar, today sponsored by Infotech. I'm Nora Parker, webinar producer at Directions, and I'll be moderating today. Behind the scenes helping me push buttons is my colleague Lynette Qualia. So if you have any questions or technical difficulties during the webinar, just ping us on the chat interface and we should be able to help. Today, as the title suggests, we're going to learn about 3D terrain data. This is a pretty complicated subject and a pretty fast-paced webinar. I feel like it's going to try to cover a lot of the ground that we would have done in a full semester back in grad school. And by the way, my master's thesis back in 1987 was on the topic of digital elevation models and whether you could use them to automatically establish drainages. I was using PMAP at the time, if that tells you anything. And to make a long story short, yes, you can indeed delineate drainage basins using digital terrain data and the algorithms available back in the day, but with one major caveat, and that is that you have to have really good data, which we didn't have at the time. But fast forward more than 25 years, and here we are with tools and techniques that have advanced by leaps and bounds, as our friends at Infotech will explain. Now, I do want to mention that our speakers at Infotech are going to be willing to give you a free analysis of your data needs based on your applications and what data you already have on hand. So please keep that in mind as we go through today's webinar. You might want to consider jotting down some questions as we proceed, questions that are too specific for our individual, for your individual situation to cover during the Q&A. So do just keep in mind that you'll be able to ask our speakers some very specific questions. We'll give you the speakers' emails at the end of the webinar, and of course those will be in our follow-up note as well. So just consider that. So I will be introducing everybody as we go along, but we do have a very packed agenda, so I want to go ahead and get started. So we have more than 450 people registered for today's webinar, and you can get a sense of their broad geographic distribution on this map, and I put the pins in the map based on how many people work at each organization. We've got 6 out of 7 continents represented, which is terrific. And I'm wondering if any of those far-flung dots are actually here today. If you're joining us from somewhere where you really ought to be already in bed or at least at dinner, please give me a holler in the chat box. I've already heard from Nadir in Sudan. Thanks so much for joining us today, Nadir. Do we have any other people from the continent of Africa or any Australians? I know we have one Australian helping us on the Infotech end, and we do appreciate that. But anyways, go ahead and say hi to me in the chat box, and let's keep going, as we do have a lot of people. Oh, here we have somebody, Najed from KSA. Hi, thanks for joining us. All right, and here we have, oh my goodness, Erica from South Africa. You guys have Khan from Turkey. Thanks so much for joining us, everybody. That's great. I'll keep an eye on the chat box. We have somebody, Mohammed from Malaysia, Joseph from Lebanon. That's above and beyond the call of duty, you guys. We really, really appreciate you being here today. So now just a few housekeeping tips. We do encourage you to ask questions, and we'll do our best to address as many of them as possible. You can also send us a tweet at DirectionsMag and include the hashtag #TerrainWebinar. I'll keep an eye on that. And have Yusuf saying hi. He doesn't say where he's from, but I bet it's from somewhere far away. You can access a PDF copy of the slides and a link to the bios for our speakers. I'm going to put the URLs to those 2 items in the questions window on the GoToWebinar interface as soon as I stop talking. Oh, Yusuf says he's from Malaysia. Thanks for being here. We'll be taking some polls during today's webinar, and we'll walk you through those when we get to them. And yes, we are recording today's webinar. Can just asked from Turkey if we're recording it, and we will be sending you a link tomorrow with in an email with instructions on how to view that recording on demand. It's also handy if you want to pass it along to your colleagues, and we'll get that to you as quickly as possible. Like I said, hopefully tomorrow. Finally, there'll be a quick survey as you exit the webinar, and we'd appreciate it if you take a second to just fill in that survey and let us know how we did today. Now, just in case you're not familiar with Directions, I just want to mention that we are best known for our online publication, Directions Magazine, and our newsletters. We're also involved in conferences and webinars, so please check us out at directionsmag.com. Now, I want to introduce our agenda real quick. We We've already heard from me, Nora. Welcome and overview. Next, I'll be introducing Drew, but we're going to do a quick poll before that. Drew is going to talk about the key elements of 3D terrain data. He'll be passing it on to Srinu, who's going to be talking about creating terrain data. And then we'll hear from Hanuman Chadagam on the business uses of terrain data, and that's where we're going to start getting into the case studies, which we'll be hearing from all three of our speakers. So now I'm going to go ahead and launch our first poll. And I'd really appreciate it if you take a minute to tell us how important is terrain data to your organization. Is it very important, somewhat important, not so important, or maybe it's not sure? So you can go ahead and register your vote there. And I see that you're voting at a very fast clip. I do appreciate that, as I want to keep the webinar moving, as we do have a very packed agenda. So, all right, so it looks like most of you have voted. So if you haven't voted yet, please do go ahead and do so, because I'm going to close this up in about 3 seconds. 3, 2, 1. All right, closing it. Okay, I'm going to share the results. We have almost half of you saying it's very important, and another almost 40% of you saying it's somewhat important. So that's almost 90% very or somewhat important. 3% not at all important to your organization, and 11% not really sure. So good. So those of you who said very somewhat and not sure, well, actually, I think everybody's going to get something out of this. So let me go ahead and introduce you to Drew. Drew Marin is a geospatial engineering manager for Infotech, and he has over 12 years of experience in GIS, IT, and sales. Drew, thanks so much for being here today.
Thanks, Nora. It's good to be here, and I'm glad to see that people have joined from around the world to learn a little bit more about terrain data. Terrain data is important for many applications, especially those that call for visualization and near real-time operations. With the advent of sophisticated software, more advanced technology, and more accessibility to remote sensing data, users can now create, visualize the world in a different dimension. However, you need accurate terrain data to do so. Do you know how to get the most accurate terrain model for your business needs? In this webinar, you will be given an introduction into terrain data, including what it is and where it comes from, how it's generated, and why it's so important for making business decisions. The key takeaways will include the following: the process for terrain data creation, why it's important to have an accurate terrain model, how to access terrain data, and finally, lessons learned from relevant case studies. Before we dive into this topic a little further, there are a few common terms we want to cover so we don't lose anybody with all the acronyms that will be used freely during this webinar. All terrain data viewed in an environment like a computer, smartphone, or tablet is all digital forms of what you see in nature. Digital elevation model, or DEM, is a 3D rendering of the Earth's surface considering physical and man-made features. This means that the data contained in these files represent the spatial elevation of terrain in the form of elevation points, known as mass points, and break lines, which are linear features that represent the abrupt changes in the terrain. Variations of the DEM based on the features that are represented are a digital terrain model, or DTM, and a digital surface model, or DSM. A DTM is an elevation model of the bare Earth representing only the terrain and physical features of the Earth's surface. These models do not include elevation of above-ground features such as vegetation, like tall trees, and man-made structures, such as buildings, towers, and overpasses. A DSM is a more encompassing elevation model, which is both natural and artificial features on the ground, LiDAR will be discussed a little later on in this webinar on how it is used as source data, but right now I'd like to give a simple explanation of what LiDAR is. LiDAR stands for Light Detection and Ranging. It's an optical remote sensing technology that can measure the distance to an object, such as trees, buildings, and the grounds, and places a point in X, Y, and Z space. In addition, each point will have an intensity range to give the user the understanding of how to properly classify an object. Once classified, the LiDAR data can be separated into first return points, second and third if you need it for your project, bare Earth, and classified above ground features. A DEM and DSM can be produced from that. To give a more direct and simple definition, LiDAR is a very dense mass point with additional characteristics. Classified LiDAR data, along with aerial or satellite imagery, will produce a more accurate DEM and DSM due to incorporated benefits for visual appearance of the image in the dense elevation data. Terrain quality and accuracy are preset parameters that are based on the project scope. Both quality and accuracy follow mapping scales and industry standards like National Map Accuracy Standards, NMAS, American Society for Photogrammetry and Remote Sensing, ASPRS, and International Standard Organization, ISO, to name a few. The higher the mapping scale required, the more accurate your terrain will be. The more accurate your terrain generally implies more quality control. Having provided you with a brief definition of the common terms and acronyms, we now would like to walk you through the process in creating the terrain. I now pass it back to you, Nora.
Thank you so much for that primer on acronyms, Drew. I'd like to introduce everybody now to Srinu Ratnala. He is a geospatial solutions subject matter expert and senior project manager at Infotech Enterprises, and he has 14 years of experience in the geospatial industry. Srinu, thanks so much for joining us today. Over to you.
Thanks, Nora. It's good to be here. In order to create terrain data, it's important to understand what the end user's requirements are in terms of the application that it will be used for. There are a lot of variables that need to be factored into your decision, which include but not limited to accuracy, frequency of capture, spatial resolution, or the grid size, features required to be captured, and of course the cost. During the course of this webinar, we'll be discussed about these in detail. To create terrain data, it's necessary to combine source data, software, process, accuracy, infrastructure, and the end client's preferences to allow for proper scalability and workload volumes. To get a better idea of creating terrain data, I will now talk in more detail on each of these. Source data is the primary component for terrain data creation. Aerial, satellite, and LiDAR sensors offer the end client to see what best suits for their project requirements. Different types of applications may require different accuracies. Depending on this requirement, one has to choose an effective source to meet the budget and scope. Terrain data can be derived from various sources such as GPS points, aerial or satellite imagery, like satellite stereo imagery, that is, LiDAR data, and of course legacy data that can be digitized from a cartographic or topographic map. The choice of data sources and terrain data sampling techniques are critical for quality of any resulting DEM. For large-scale applications and higher accuracy terrain models, one can choose aerial or LiDAR imaging or even both. For small scale and regions of less accessibility, satellite stereo imagery is a good option. The most cost-effective and technologically viable solution in the current digital era to create a terrain data is possible through digital stereo imagery, LiDAR, or combination of the two. For digital stereo imagery, the choice of intelligence goes between airborne or satellite, depending on the accuracy, schedule, and the budget. No matter what the size of the project is yours, project area is, terrain data can be hundreds of billions of features. Software modules are needed to properly handle the data and allow for rigorous computations. There are many viable and sophisticated software packages available in the market, of which I have mentioned a few in this slide. It's important to use one of these softwares effectively. If you use a non-proven software, it can lead you to inaccurate results and may result in higher manual completion and overall cost. Once the software data type and the software are set, The actual data processing has to be performed through various steps, which are very critical to produce an accurate terrain model. For aerial or satellite imaging sensors, the process begins with aerial or multi-sensor triangulation. Normally we call it as AT or DAT, digital aerial triangulation. That is the common term used. This process enables to orient the images to the required Earth coordinate system and relatively orient the images to the other, to each other, and remove any parallax and develop a good stereo model. The accuracies achieved in this process are more critical for terrain data development, as the results from triangulation will be the basis for the later process. Through semi-automatic methods, that is interactive methods, the break lines in the terrain can be collected, and those are nothing but the breaks in the terrains can be collected, and those are called the break lines. The elevation points supplemented with the break lines will give more accurate terrain, that is normally called as the DTM. As an individual feature, the elevation points and break lines do not bear any correlation. These features will be interpolated together to produce a continuous surface model, which is called as a TIN. These TIN models will be base for later outputs such as the DEM or the grid surface. A DSM can be created from the TIN supplemented with the above ground features such as structures and vegetation. Also, the TIN model can be used for contour generation, shaded relief, and aspect models. Another factor to remember during the process of triangulation, terrain model generation, is the accuracies can be achieved from the source. However, the choice is based on the requirements and the use of the data for various applications. For required accuracies, one can switch between imaging sensors or can use a hybrid approach. As you see in the table, higher accuracies can be achieved from LiDAR data compared to aerial or satellite imagery. Process steps required to achieve any level of accuracy also have to be part of these processes. For example, from stereo imagery, first generate terrain model utilizing the algorithms available in the software. Using software platforms like SocketSet or SSK Image Station, you can manipulate the terrain for various densities interactively. The data can be edited by using key features and deleting unwanted or erroneous points. Once editing is completed, you can drape the DTM, that is the terrain model, on the imagery and perform quality checks for relative accuracies, also using ground checks for the absolute accuracies. Once checks are completed, process the data through various smoothing algorithms to produce an aesthetically pleasing and spatially accurate DEM. Now, I would like to showcase the visual appearance of a DEM with reference to the accuracy and the mapping scales and the details represented on the terrain models. Larger the mapping scale, more details will be represented and data will be more accurate. DEM shown here is for a 40 scale mapping, which was generated at 10-foot grid interval and with more details. And the DEM data shown here is from a 100 scale mapping at the same 10-foot grid spacing, but with less accurate, less details. Similarly, satellite stereo imageries can be used to produce coarse or the coarse high resolution DEMs ranging from 2 meters to 8 meters. In some cases, even you can generate even at lower resolutions. Here, 2-meter spacing DEM is represented with finer details, and of course, the satellite imagery used for this data processing has been has a high resolution, that is like 50 centimeters or so, and has been triangulated with ground control points. In such case, vertical absolute accuracies can be achieved up to 2 meters. As you see here, 4 meter spacing DEM is represented with moderate details, and accuracies from this data can be achieved up to 5 meters, and this is with the triangle without ground control points. In this case, 8 meter or less spacing DEM is represented with less details, and most of the terrain features are generalized. The accuracy will be low for these resolutions, that is 10 meters or below, as the data is coarse. This sort of data is useful for regional reconnaissance studies and visualization of the terrain. As mentioned before, LiDAR data can be used to produce high accurate DEMs. It has the advantage of high density point cloud to produce a very high resolution and precise output. From a precise output from an accurately classified data. LiDAR can be used for accurate terrain models, vegetation and infrastructure classification, utility networks, and of course for the DSM generation. Overall, the choice of source, whether it's aerial, satellite, and the LiDAR, depends on the requirement and accuracies to be achieved for a given project, and of course the budget. Now I hand it over back to you, Nora. Thank you.
Thanks so much, Srinu. I feel like I just went to school. That's a very good overview there. I would like to introduce everyone to our last speaker now. Dr. Hanuman Chodagam has 16 years experience in the geospatial industry under various business segments, and he also holds a doctorate in remote sensing. Hanuman, thanks so much for joining us today.
Thanks, Nora. It's great to be here on this webinar. As the technology is becoming more sophisticated with a variety of cost-effective imagery sensors and high-performance computer technology, the use of terrain database is becoming more demanding these days. Especially the people do not rely on historical data anymore to carry out their business activities. Today, it's all about getting and using the current up-to-date information on the existing conditions and using that for their effective on-spot decisions. As a result, high-resolution terrain models are cutting-edge deliverables to government, mining, oil and gas, defense, and various other natural resource management organizations. In the following slides, we are going to discuss the use of high-resolution terrain data models for a variety of industries like government, transportation, as well as mining. Let's see how government organizations can use the terrain data in various applications. As you know, most of their applications need data in a GIS. The DEM they want in a raster format that can pop up on the desktops and can do analysis. This is used to simulate or visualize the ground realities in order to make better decisions. I now hand it over to Srinu, who will talk on what case study on one of our government clients. Srinu, over to you.
Thanks, Hanuman. The case study shown here demonstrates the use of terrain data for urban mapping and stormwater studies for a city planning department. The area is low-lying with relatively flat terrain, and most of the area is near or below sea level. Also, as you see here, the area has the shoreline on all three sides. Over the years, the client was utilizing very coarse DEM, and the coastline information was not up to date. Due to inaccurate data, the models created by public works and the stormwater departments were not yielding the expected results. In order to achieve the expected results and effective planning, terrain models were developed with hybrid approach of LiDAR and aerial photography collected at 40 scale mapping. Aerial imagery and LiDAR was acquired at low tide to capture the accurate coastline for both horizontal and vertical precision. Aerial imagery was triangulated with high precision ground control network and LiDAR data was classified to produce a Bay-Red point cloud. Bay-Red data was then supplemented with break lines and other hydro features compiled from the aerial imagery at a foot or better accuracy. DTM and DSM models were generated from the classified LiDAR data and the breakline features to produce high precision terrain models to meet the city requirements. With the combination of LiDAR and the large-scale aerial imagery, the city achieved desired accuracies while effectively utilizing the terrain data for projects in areas of urban planning, environmental impact assessment, and simulated models for the stormwater and floodplain studies. I will now hand it over to Drew to discuss about the transportation industry case studies. Take it, Drew.
Thanks, Shanu. The next two case studies will support the transportation industry. One will be more on the ground transportation and the other on the air transportation. The first one I will address will be on the ground transportation where the DEM data is used for highway mapping. This case study focuses on the way terrain data plays an integral part on ground transportation related projects. Clients with transportation needs are faced with the challenge that terrain data for the current infrastructure is as close to perfect as possible. They also must have highly accurate terrain for future expansion and development areas. Due to the high resolution, accuracy constraints, and limited extent of the area, satellite is not a viable solution. LiDAR would be beneficial for these projects, but the client does not have the budget in place to support this. An aerial capture at large scale with ground control point meets the scope and budgetary needs. Once aerial source data is captured and triangulated, terrain data collected with manual compilation and elevation points, and the break lines, which include transportation-related features like edge of pavement, shoulders, embankments, ditches, and retaining walls, to name a few. Upon final completion of terrain data and mapping, the user will now be able to visualize and analyze the desktop engineering to create highway corridor models. Areas that require attention can be analyzed first using these models. This analysis allows for proper identification of the field verification that needs to be re-engineered and or constructed for construction. As we just talked about ground transportation, we now are switching to the air transportation case study. Just as ground transportation requires an accurate terrain, air transportation also requires terrain models. Airports are required to have consistent terrain data in order to meet industry specification standards around the world. These terrain models need to be able to support plane navigation in and around a specific airport. As airports expand to meet customer demand, they need to maintain their data. Based on the industry standard, satellite sensor imagery is the preferred source data as a whole. Some airports do use aerial and LiDAR collection, but our case study focuses on the aerial collection side only. Satellite collection avoids the security clearance and congestion of airspace that aerial imagery and LiDAR would need, and still meets the resolution requirements to generate DEM data. Since planes are mostly in the air, there is no need for high precision DEM of the airport surrounding. This DEM is used for visualizing of the region and identify major terrain changes in the flight path. A DSM is also used similarly as planes need to know where major structures, utility poles, and vegetation like tall trees are located. The air transportation industry can utilize the DEM model in many different ways. Airlines can train their pilots using flightless simulators, use real-time terrain data. Emergency dispatch can respond faster to situations, and planes can navigate more effectively and efficiently in and around an airport. The transportation industry as a whole used terrain data as a source for many different initiatives as we have presented here. I will now pass it back to you, Hanuman.
Thanks, Drew. Fantastic. Now, having seen the surface, now we'll go down below the surface and see what exploration industry does. The exploration industry always has a thirst for information, especially regarding the data related to natural resources, mining, and mine activities. Taking the mining scenario, all the opencast mines have a bench cut process, which is typical in nature, that carry out operations together for years and years. So what is the constant change that you all see? It is nothing but a terrain activity. Let's look at an example showing how the terrain information is useful for exploration industry. This is a mine that you see on the screen. We have taken as a case study to develop what remote sensing sensors can benefit the industry. This is a base metal mine which is undergoing operations needing some support on the ground activities for visualization and real-world changes. So the first question comes to the mind that what is the accuracy and which sensor would be useful? It's known that there are sensors that are sophisticated enough to be the best in specific resolutions. For example, as you all know, it's a WorldView 2, which is at 50 centimeters, which is one of the best resolutions that can be used. And of course, this does not give you the high precision information, but the information can be generated, which is very useful for preliminary understanding and better decision making. This is what you see on the screen is a full length of WorldView sensor stereo imagery of that particular area, which has been subjected to satellite stereo photogrammetry. The pair of images have undergone rigorous triangulation process using RPC parameters. You probably wonder how RPC can suffice the needs. Actually, it is the operator techniques and sensor precision that determines the ability to get a high resolution. Since this was a test which we had supported the industries without going to the ground, what information, how much information, what value of information, and what accuracy of information could be provided. This proved to be very successful for us, saving both time and cost for the customer. There are four basic things what can be derived from this: the shape and the situation of the terrain, ground reality of the activities that's happening on the ground, and what volume changes, and visualizing the models on your desktop. Now, what is the solution that we have used here? By using 3D techniques on the stereo satellite imagery, we can develop DTM and DSM. Then these images are draped onto the imagery I can visualize. Once the terrain is ready, this complete information we can review the details of ground and analyze in more practical manner. In addition, we can also visualize the changes before and after using temporal data. In this method, we can use a subtraction process where we subtract the new DEM versus the old DEM in order to get an approximation of volume changes over a period of time. There are also substantial benefits that can be realized by using these DEMs. The satellite DTM and DSM forms as the first-hand terrain information for immediate planning. Before blowing away money on the ground methods or high technology methods, this would give a maximum information for what is required and how intelligent interpretation can be done using satellite imagery. It's also cost-effective and time advantage. These methods prove to be highly cost-effective and advantageous in building relations on various parameters, especially for testing and evaluation of the requirement, such as mine layout planning or tenement mapping or volume calculations or changes that takes place, what we call as change detection, and this is on a regional scale assessment. And we can get a same data one would get on the ground. We can also perform analysis for better decision making. Also, there is another benefit to be known: what percentage of changes that take place in terms of overburden calculation. Here you can see a mine from the mine floor to the surface. You can visualize clearly and you can calculate the volume taking the area calculations. It may not be precise, but in terms of the exact numbers, one can get a fairly an idea of volumes and changes just by sitting at the desk. This can save a lot of time for a quick decision as well as a lot of money that can be saved by getting a good decision. Now I hand over to Drew for concluding this session.
Thanks, Hanuman and Srinu. What we have presented here today is to give you a sampling of how terrain data is used throughout many industries. It is a core data set that allows for many users to intelligently analyze a geographic area. Source data allows for users to economically and efficiently navigate through this selection process in order to come out with the best solution fit for them. The more knowledgeable the user, the better solution can be provided. Thank you again, and then I'll pass it back to you, Nora.
Oh, thanks. Thanks a lot, Drew. Nice job on the case studies, guys. Those are really good. Okay, so we have a couple of polls that we want to ask you guys now. Go ahead and launch this one. So the folks at Infotech were interested in knowing, do you have a sense of what your needs are? I mean, one of the hardest things, and a lot of the questions that are coming in have to do with, well, what kind of data do I need to do this, that, or the other? So we want to get a sense of, do you know what type of terrain data you need? Yes, I know what I need. No, I would need help to understand exactly what I need. I mean, you might have a vague sense of what you need, but you might need some help pinning it down, or maybe this question doesn't apply to you. All right, good. So looks like we have almost all of you have voted, and I'm going to go ahead and keep moving here. So if you haven't voted yet, we do have a lot of questions that have come in from the audience, so I want to have an opportunity to get to those. So, okay, so I'm going to go ahead and close this up. If you haven't voted, please do so now because it's going away. All right. Closing and sharing. So about 60% of you do know what you need, but 20% of you are in that category of needing some help understanding the nitty-gritty of exactly what you need. You know, is it LiDAR? Is it aerial? What would be the difference? How would the costs vary? How do I go about acquiring it, et cetera, et cetera. Okay, I'm going to go ahead and hide that one. And we have another poll that we want to ask you. So this one really kind of has more to do with your life cycle, your data life cycle. From what you've learned today, where are you with your need for terrain data? We're asking you to just pick one, although definitely we can see instances where more than one of these might apply, but pick the one that's the most representative for you. So the choices are create an entirely new source of data, capture, refresh and update an existing data set that you have, maintain, this would be ongoing support of data that you have, or I don't know, this doesn't apply to me. Great. So, okay. And we have more and more questions coming in too, so I don't want to stall here for too long. All right, so if you haven't voted, please go ahead and do so. And I'm going to close it up in just a minute here, just a second here. So I'm going to go ahead and close this up now and share those results again. So here we have a pretty good split between create, 30%, refresh, 25%. A few fewer of you are in maintain mode, and about a third of you don't know or it doesn't apply to you. So I'm going to go ahead and close that as well. And now I want to give you guys everybody's emails here, and I'll put these in the chat box in just a minute too, so you can grab those. Basically, as I mentioned at the beginning, these emails are important if you want to follow up with the individual speakers. If you are located or your data needs are located in the Americas, Drew and Shrinu are the right people to reach out to. And then if you're basically anywhere outside of the Americas, you want to reach out to Hanuman. So I'll leave those up for just another minute or two. And then we're going to start diving into your questions. So I'm going to leave that up and go ahead and ask the speakers to open your mics back up and come on in and help us with a lot of these questions. So the first one, is there any alternate DEM source to track the assets along a rail or road corridor other than aerial remote sensing sensors? Drew, can you help us with that one?
Yes, I was going to nominate myself. Yeah, based on the webinar timelines, there is another form of LiDAR. We really focused on the aerial LiDAR. There is something called terrestrial LiDAR, or better known as mobile LiDAR. And that's one recent technology that is being adopted in many industries. However, it has some certain limitations and it's mostly for small area size or corridor projects. What the webinar we were trying to achieve today was more on larger areas or larger volumes or remote areas. So if we had another hour to this webinar, we would have touched upon this.
Okay, great. Okay, so now another one for you, Drew. Can we use DEM data for urban planning and how? And maybe Srinu and Hanuman would like to chime in on that one as well.
So you want me to touch on
yes,
the
please.
question one more time?
Yeah, sure. It's can we use DEM data for urban planning?
Absolutely. If you're talking about a very dense area in terms of a lot of construction with buildings and road networks and a lot of people, we do recommend that you have a very accurate high-resolution DEM, similar to a 40 scale mapping or as close to engineering scale, which is more like a 20 or 25 scale mapping based on your budgetary needs. This will get you more details in those areas where there might be tall buildings like in New York City or in Hong Kong or places like that.
Okay, great. I am getting swamped with questions, guys. Sorry, I'm getting a little bit behind here. Okay, so next, what are the best accuracies that can be achieved from satellite sensors? And that one's going to go to you, Srinu.
The best accuracies that can be achieved based on the use of the ground control points, a good network of ground control points, it could be up to 1 to 2 meters. The higher the resolution of the satellite imagery, like Worldview 2 or GeoEye 2 or 1, whatever, so based on the resolution of the satellites and the rigorous models, and when it's combined with the good ground control network, obviously the accuracy can be achieved up to 2 meters.
Okay, great. All righty. So Mohammed wants to know, this one's going to go to you, Srinu, as well. Data fusion with LiDAR data for building extraction is usually said to be helpful to create NDSM or normalized DSM. How can you create a normalized DSM, NDSM?
For that purpose, like that is, yes, that's another technology that's called the data fusion. LiDAR values, the elevation values from the LiDAR will be taken and it will be combined with the imagery or from the vector model of the building to create the DSM models. So that will give precise information about the DSM. For example, in the LiDAR DSM points, it may not be possible for all the points to be placed exactly fall to the edge of the building, but when we combine that data with the vector data or the imagery, so then the outlines of the buildings can be depicted and the data can be fused. Okay.
Okay, so now this one goes to you, Hanuman. In the exploration case study, you mentioned stereophotogrammetric technique as part of the solution. Is there more than one stereophotogrammetric technique that could be used?
Yes, of course. The stereo can be applied for both aerial and satellite imagery and also for LiDAR. These techniques can be used for different sensors to achieve different accuracies. So aerial and satellite, like for the resolution base, like if it is a 1 meter, 2 meter resolutions, we can go with stereo satellite imagery, and whereas for example, high resolution, high scale, 40 scale mapping, we can use airborne imagery for stereophotogrammetry techniques.
Okay, great. Okay, so bear with me, guys. The questions are coming in fast and furious. I feel like I'm getting a little overwhelmed here, but we do appreciate that. So this one goes to you, Srinu. James wants to know, for your 1 inch to 40 foot and your 1 inch to 100 foot aerial samples, what was your data source, i.e., from which sensor did you obtain the aerial data?
The aerial data is nowadays we are using mostly the digital cameras, whether it's Vexel or the DMC. So those the aerial imagery can be acquired with 7 centimeters for the scale mapping. That is nothing but the it can be produced with around 3-inch photography.
Mm-hmm.
So that is the source used for the scale mapping.
Okay, great. Okay, another one for you, Srinu. What challenges would you run into if the data source wasn't adequate for a large-scale application?
Yeah, that's a good question because we talked a lot about the accuracies. Yeah, if the recommended source is not chosen properly, so then the accuracies to be achieved, we can't achieve the required accuracies, and of course we can one can see the actual results of the ground that was intended for.
Okay.
So that impacts the actual output.
Okay. Another one, let's see, this one's going to go to Hanuman. Joseph wants to know, why are you not considering point cloud for shorelines, as it is cheaper to fly and vegetation is not a factory? I guess that's back to that, that one case study that we showed.
Can you repeat the question, please, Nora?
Yes. It has to do with why not use point clouds for establishing the shoreline. So why are you not considering point cloud for shorelines, as it is cheaper to fly? Mm-hmm.
Yeah, I think I will answer. I can answer that.
Okay.
As we have shown in the case study for the government, in order to produce the accurate shoreline, we use the combination of aerial photography and the LiDAR. So that as described in the case study, the data was acquired at the low tide so that we can see most of the ground and the water levels we can easily predict. And the LiDAR data was used as a source. And in addition to that, aerial photography was also used as another source, because from the aerial images we can properly, accurately delineate the shoreline, as well as when it's combined with the LiDAR imagery, so the elevation can give more accurate details, more accurate information.
Oh, okay.
So
I didn't know that.
It's a combination of both. Yeah.
Oh, that's interesting. I learned something. Okay. Drew, this one's for you. Somebody's worried about sticker shock. Is LiDAR an expensive option? Talk to us a little bit about costs on LiDAR.
Well, it can be yes and no. You are talking about a larger area, such as I tend to use as a nice rule of thumb, non-corridor mapping projects, so nothing like a road where you just capture a quarter of a mile or a quarter of a kilometer on each side and you go up for a period of miles. You're talking about a regional area. I tend to say that anything above 25 to 30 square miles, you can start considering using LiDAR data, which will offset the amount of manual compilation needed in order to collect adequate mass points. So anything above 25 to 50 square miles, or 25 to 30 square miles, I would think that it would be a nice rule of thumb that it would offset and there would be a nominal increase compared to the additional information that you would get from using LiDAR data.
Okay. And talking about prices, while we've got you, Drew, somebody wants to know, where can you get digital elevation model data for a cheap price, digital elevation model with a less than 2-foot resolution?
Nominal cost or free? Sometimes, if I don't know exactly where this person is referencing, if you're talking about North America or the U.S. specifically, a lot of the times state governments have acquisition for either the entire state at a certain scale. The federal government has some available as well. At this time, I'm not quite sure if I want to give a link and specific agency, but I would first contact your county government to see, or your regional government, if they have a geospatial department, or your public works department, to contact them to see if they have something available. And if they don't, contact you to a state geographic information officer or state department that might have that. And if not, go up to the federal level, whether or not you can contact USGS or some little agency like that.
Okay. And I am putting the emails for our speakers into the chat box now. Hopefully I'm not going to have any typos. And then also we noticed some of the slides had chopped off at the bottom, and we will do our best to try to get that fixed for the recording that we send out. All right, so more questions here. Can the data be used for line of sight analysis? And I think we want to send that one to you, Hanu.
Yes, of course, definitely this, the terrain data, the digital surface modeling can be used for this line of sight, provided all the buildings and building material are complete, and the top of the buildings is covered complete with the DEMs, and using a point of cover from a single center of the urban areas that can be covered the line of sight here.
Okay.
Yeah, I'd like to add on top of that a little bit as well from a different perspective. Line of sight is more of a byproduct of once you have your source data and then you create your terrain or your surface model. There are plenty of available softwares that are available that can support. You have all of the materials in place. We recommend that you look into a third-party software that would be able to assist you, whether it's there's Esri that is fairly prevalent in the government world and around the world. But if you're talking about LiDAR, there's some more customized software such as QT Modeler that's very helpful, and that will give you a very quick line of sight analysis, and you can create maps and source materials from that. So it does depend on what you want to achieve and who your audience is to achieve those goals.
Okay. Back to cheap data. What are the web sources for free data for DEM, DSM? Srinu, Drew, can you throw out any ideas on that?
So the web sources, I believe it's a similar question. So I would go back and contact nowadays almost every local government agency that has mapping already created, has it available to you through their website. If they don't have that, I would contact your state government, and if not, go up to the federal level, because any one of those levels will have some source available already being able to view, whether it's served up on the server or on the cloud, and you can access it from there.
Okay, great.
The most free available around the world would be Google Earth. That is, you can't use that to derive any accuracies from it. But if you just want to see how high is this mountain and how high up this road is going up the mountain, Google Earth or other viewers such as Apple Maps or Bing Maps will have those type of elevation data that's very coarse, and you can't derive too much from it because it doesn't have an accuracy constraint to it. But you can visually see what it looks like.
Okay. Okay. Another one. Can one of the presenters chime in on this one? In each of your opinions, what would be the best and easiest software package? Oh, this is going to be interesting. Software package to view and create and analyze the terrain data sets produced from the various sources mentioned, but especially LiDAR.
To view LiDAR?
To view, create, and analyze terrain data.
Well, to create LiDAR data, there isn't one, Srinu could probably chime in or Hanu can chime in, but there probably isn't one best that will fit all three. If money is no objective, which it sounds like it wasn't addressed here, there are plenty available sources. Overwatch has one available, Esri has some type of packages available, not to necessarily create it. I did mention Qt Modeler. That's a very good one for LiDAR data. BAE has Socket and Socket GXP that would be available. Srinu and Hanu, if you wanted to chime in, but there isn't one specific one because it really does depend. Infotech, who does a large amount of the production for some of these clients and case studies we mentioned, needs different things. Yeah,
it is TerraSolid.
Different. Yeah, so it's just TerraSolid as well as what Hanu said. Needs something different than what a government agency would get once we develop and produce it and provide it to them.
Okay. Well, you guys will be glad to know that the audience is chiming in with their favorites as well as we've been going. And also, Andrea in Italy wants us to know that Aster from NASA has some free DEM data, so that's a nice resource for folks. Are there hardware and software limitations in the use of LiDAR? Mobile especially, in large-scale engineering terrain data projects? So Drew and Hanu, maybe you could take that one?
I still think today there are no more limitations on accessing large amounts of data with hardware constraints. The issue is how much money you have to pay for it. They have these hardware now are very efficient in processing data for you to view almost simultaneously when you click on it. It does depend on your budget. If you go personally and you look at Dell.com, you can customize a laptop. The base model can cost you $500, but based on the amount of RAM and hard drive space, you can increase that laptop fivefold based on the amount of RAM and memory that you put into it. So it really does depend on your budget. But short answer is no. There is no more. I feel comfortable in saying that there is no more budgetary or constraints on the hardware side to support real-time LiDAR viewing, especially on the mobile or terrestrial side.
Okay. Hanu, did you want to add anything on that?
Yeah, that's all. Yeah, thank you.
Okay. So I hope I get this next question right. 3D data collection and processing is expensive. I think this has to do with justification, project justification. So 3D data collection and processing is expensive. How can the use by private business organizations be encouraged without too much cost, overburdening with cost? So Drew, maybe you could take that one?
So they're asking whether or not 3D data, the cost to generate and use 3D data?
Yeah, basically, how do you justify that for private businesses?
It really does depend on what the business, what the business is trying to support. There are free. If you're just looking at it, I've referenced this before. There are some third-party applications that are available: Apple Maps, Google Earth, Bing Maps. All those have 3D modeling available that you can actually go in and view from there. If you want to create your own or have your own created, there are some different levels of degree or level of difficulty in terms of the models generated. We tend to level of difficulty usually runs from 1 to 4. A 1 being a simple 3D model with 4 points on the ground, 4 points for the roof, 2 points for the pitched roof, and there it is, you're done.
Okay.
And then it can range to a more detailed roof line for a model, and then you can do synthetic texturing of the outside, and then you can actually do more detailed texturing of the outside. The cost really comes from texturing the building to make it look more real-time of what appeals in the earth. So to create the 3D model itself is not the cost, it's more in the texturing. You can drape an image on top of it, but you'll have smearing and smudging once it drapes on top of the edge. So it really does depend on how accurate terrain is, how accurate your model is, how accurate your image is, to go from there to just drape it on there. And your elevation, if you're talking about a very mountainous terrain and all that stuff. So it really does depend on what options you need there.
You know what? we're going to have to leave it there. Time has flown. I did not realize that we were at the top of the hour, but I know that we have only scratched the surface of your questions, folks, and I do apologize for that. But do know that we will get the emails of our speakers out to you in a thank you note tomorrow, and I've already put them in the chat box if you want to grab them from there. Remember that Drew and Srinu are the right people to contact with questions in the Americas, and Hanuman is the right contact for questions anywhere else. And a couple notes. I want to let you know that if you are working on your certification for your GISP, this webinar can be applied to the EDU 3 points. Drop me an email if you need a certificate. I just want to thank everybody who attended, and also our speakers, Drew, Srinu, and Hanuman. Great job. Really appreciate it. Until next time, this is your moderator, Nora Parker. Thanks for coming, and be sure to tell a friend about Directions Magazine. Bye for now.